Good morning. Today we're going to be working with adding and subtracting rational expressions. In order to do this, there's some things that you need to recall. Part of it is from 6-8, having to do with where you can divide out ones and where you can't. I'll get to that in just a minute. The other part has to do with, obviously, adding and subtracting fractions. So we need to kind of remember how to do that. I'm going to zoom in a little. No, that would be out. Zoom in so you can better see those. Oops, there we are. That'll work. Okay, so when you're adding or subtracting fractions, the denominator stays the same. You have to have a common denominator in order to add or subtract fractions. So this one's subtracting 8 minus 3 is 5. 11 stays the same. On the second one, we do not have a common denominator. We have 3 and we have 6. So in this particular case, what we can do is multiply the first one by 2 over 2. And that will give us 2x over 6 minus 2 over 6. Keeping in mind that 2x and 2 are not like terms, 2x minus 2 over 6. That can also be reduced to x minus 1 over 3, since each of those terms is divisible by 2. On the last one, I'm going to run out of room for, we don't have a common denominator on either, so what we can do is take our denominator for the first one and multiply the second one by 3 over 3. Keep in mind, as we talked about last class, the reason that we're able to do that is because anything divided by itself is always 1, and you can multiply 1 by anything without changing its numerical value. So we multiply the other one by 5 over 5. That way what we're left with is 5 over, I'm going to draw a line between those, 5 over 15 plus 6 over 15, so we get 11 over 15. So when we have unlike denominators, we have to typically have to multiply by something to change one or both of those denominators. Now, if we have something like number 2a, I'm going to do a couple from 2 and then one from 3. These processes get fairly long because not only are we making sure we have a common denominator, but then we're also factoring to make sure we divide out as much as we possibly can. So on both of these denominators, we have 2x plus x minus 21 as our denominator, so that stays the same. On the top, we've got 2x plus 7 divided by 2x squared plus x minus 21. Now, what we learned in the last class was that if we are in standard form or written as a sum, which we currently are, we can't start canceling things out. I can't divide out a 2x here for a number of reasons, but one of those reasons is that these things are not being multiplied, and we can only cancel things out to divide out to 1 if things are being multiplied, and right now they're being added and subtracted. So what we need to do is rewrite 2x squared plus x minus 21 as a product instead of as a sum, and we do that by factoring. I'm going to use the box and diamond method because that's what most of my students are comfortable with. If you use another method, such as the algebraic grouping method, you're perfectly welcome to do that as long as you're getting the same outcome. We are good to go. Alright, so we take our first and our last term, multiply those to get negative 42x squared, and then our middle term, x. So I want factors of 42. So 1 and 42, 2 and 21, 3 and 14, 4, not divisible by 4, not divisible by 5, and then 6 and 7. Because this process is only necessary if you can't think of those side numbers right away, but it's a process I highly recommend because especially when negatives are involved, some people tend to jump to the wrong ones. So if I have a negative for the top number, that means that one of my terms is negative because a positive times a negative gives you a negative. If the bottom number is positive, that means that my smaller number is going to be the negative one. So 6 and 7, negative 6 and 7 have a sum of 1. So negative 6x and 7x. go in those boxes. Then I have to be careful about where I factor out a greatest common factor. So I can't factor out a 2x from both 7x and 2x squared. I can only take an x out there. I can take a 2x out of negative 6x and 2x squared, so I factor the 2x out that direction. This is where a lot of people make mistakes when they are factoring on this part. 2x times negative 3 gives us negative 6. The other way to think about that is negative 6x divided by 2x gives us negative 3. X times 7 gives us 7x. And then you always want to double check. 7 times negative 3 gives you negative 21. So this is my bottom part factored, so I'm going to take this down here and rewrite it. Top is still 2x plus 7. And the bottom is 2x plus 7 times x minus 3. So now I'm written as a as a product, and if I look at this as being a product times 1, then I can divide out 2x plus 7 on both the top and the bottom, and what I'm left with is 1 over x minus 3. And that is my most simplified expression. Couple things to look out for as you're doing this are factoring out greatest common factors. So what I mean by that, if I look at down here at part E, if I look at 3x minus 30, I'm just going to separate this. I'm not going to do this whole problem, but some of the things that people often miss are just factoring out a greatest common factor. You want to note what both 3x and 30 are divisible by, and both of those are divisible by 3. So if I divide out a 3, I'm basically undistributing. So 3 times x would give me that 3x, and 3 times negative 10 would give me that minus 30. So then that is the 3x minus 30 factor, just taking out a greatest common factor. So that is something to keep in mind as you're looking at some of these, particularly when you're looking at binomials as opposed to trinomials. The other thing you want to watch out for are perfect square trinomials and difference of squares. Difference of squares being if you have, let's say you have x squared minus 4. X squared is a perfect square, 4 is a perfect square. So those can both be, and because you're subtracting, you can write that as x plus 2, square root of 2, x squared, square root of 4 is 2, x plus 2, and x minus 2. The reason that works out, if you do multiply that out, you get x times x, which is x squared, minus 2x, plus 2x, and then minus 4. So those middle terms add out to 0, which is why you end up with just that x squared minus 4. So as you are factoring, that's something to keep track of. You can always do that with the box and diamond, but it can be it's way, way quicker if you recognize that it's a difference of squares. On the back side is where we get a little bit more complicated, and some of them a lot more complicated. So what I want to look at up here, and just look at part A, we have a common, so we don't have a common denominator, but we do have one common factor, that 3x plus 1. So if this one is x minus 5 times 3x plus 1, what I need to do is multiply the first one, the first fraction, by x minus 5 over x minus 5. So here's what that ends up looking like. On the top, I've got x minus 5 times x, which means I'm going to distribute that x into the x and the negative 5. So that'll give me x squared minus 5x over, and I'm going to leave this factored, x minus 5, 3x plus 1, plus 2x squared minus 2 over x minus 5 times 3x plus 1. Now I have a common denominator, so I keep that common denominator and I just look at the top. I've got x squared, and because I'm adding, I don't need to worry about negatives and stuff. X squared and 2x squared gives me 3x squared. I have no other x's on the top, so I'm going to do minus 5x and then minus 2. And then my denominator, x minus 5 times 3x plus 1. What I need to do, oh, you can't see that, I'm sorry. What I need to do now is to factor this top part and see if there's anything that can be simplified. And in some cases, on some of these problems, you have to factor first before you can figure out what you need to multiply to get that common denominator. So some of these processes are really long. So first and last terms, multiply those to get negative 6x squared. They need to add up to be negative 5x. My only factors of 6 are 1 and 6 and 2 and 3. One of them has to be negative, so it can't be the 2 and the 3. It's going to be the 1 and negative 6 to add up to negative 5. So 1x and negative 6x. I need to factor out the greatest common factor for this column. So the most I can take out of there is a 3x. 3x times x gives me 3x squared. 3x times negative 2 gives me negative 6x. And x times 1 gives me that 1x. Double check, negative 2 times 1 does give me negative 2. So when I rewrite my whole answer here, on the top I have x minus 2 times 3x plus 1 over the bottom here, x minus 5 times 3x plus 1. Those two divide out to 1, and I'm left with x minus 2 over x minus 5. Something I want to be really, really aware of. This is no longer written as a product. This is written simply as a sum. So I can't cancel out x's. Once I am just adding and subtracting, once those parentheses are gone, I'm no longer written as a product, and I cannot divide things out to 1. I have to leave them as they are. So this is as simplified as I can get. So a lot of these, just to warn you, have, like part C is a very long process. You need to factor both this one and this one, figure out what greatest common factor you can, or sorry, what common denominator you can make. So it takes patience, and it does take some room, so you may need a separate sheet of paper. Anyway, so that is 6-9 in a nutshell. Adding and subtracting rational expressions. Next class, we're going to get into dealing with rationalizing imaginary denominators, and we'll go from there. Thank you very much.